And we've already used these in the previous video, but the first law is just telling us the definite integral of a constant is just equal to c times b minus a, so that's the area of a rectangle. The integral of a sum is equal to the sum of the integrals. Similar for the difference. This rule is just telling us that we can pull the constant out, which makes sense because the definite integral is just a limit. And when we worked with limits, we were allowed to pull the constant out. Rule number 5, it's easiest if you just draw like a picture of what this might look like. And this is just saying that if I have a curve and I would like to calculate the definite integral from a to b, okay, then calculating this definite integral is the same as calculating the definite integral from a to c and adding it to the definite integral from c to b, which is this guy. Okay. So in the very bottom, you have comparison properties of the integral. So for example, if my function is always greater than or equal to 0, well then the same should be true of the definite integral. If we have one function that's always greater than or equal to another function, then the same should be true for their definite integrals. Okay. In the first example here, we want to calculate the definite integral from 3 to 3 of this function. And the key thing to note is that 3 to 3, well, delta x in this case would be 3 minus 3 over n, which is 0. Okay, so this definite integral, when the bounds of integration are the same like this, the definite integral will always be 0. And basically, there's no area under a single point is one way to look at it. You can also look at it as saying, well, if I were to look at the Riemann sum, delta x would be 0. So if I multiply f of x by 0, I'm always going to have 0. So here's our second example. If you are told that the definite integral from 0 to 1 of root x is equal to 2/3, and you're also told that the definite integral from 0 to 1 of e to the x is equal to e minus 1, then find or calculate the definite integral from 0 to 1 of this function. Okay. So the nice thing is these all have the same bounds of integration. So what I'm going to do is I'm just going to rewrite this expression using the properties. And this just breaks my problem into 3 much simpler integrals. And for the first one, we can apply that very first property with constants. So this would be 2 times 1 minus 0. This integral we were actually told, oh, and I forgot my bounds of integration here. I can't forget those. So this integral we were told is equal to 2/3. And this integral right here, we were told is equal to e minus 1. So as long as we trust that. Okay, and I'm just going to simplify a little. I get 2 minus 2 plus 4e minus 4. So my final answer is just 4e minus 4. In this example, if the definite integral from 2 to 1 of f of x is equal to 3, and the definite integral from 1 to negative 1 of f of x is equal to negative 5, then find the definite integral from negative 1 to 2 of f of x. So I noticed that all my bounds of integration are different here. So the first thing I usually do is I just try to kind of organize things and get a sense of what I have and what I don't have. So I have the definite integral of my function from 2 to 1. Okay, and I'm being asked for the definite integral from 2 to negative 1. So I'm being asked for this the definite integral over this interval on the x-axis. So what I would need is if I have this definite integral and I have this definite integral from negative 1 to 1, then I can add them together to get this using a property of definite integrals. The problem is I don't have from negative 1 to 1. I actually have a reversal here. I have 1 to negative 1, which is, it's like this interval but backwards, like the b and the a have been switched. So there's a question of what can I do there? Well, the fortunate thing is that this is just equal to the negative integral from -1 to 1 of f of dx. So that tells me that this integral is actually just equal to 5. Okay, it's just the opposite of this integral. You might be wondering, why is that true? Well, remember that delta x was b minus a over n. Okay, so the only thing we're really doing differently in this case is we're just writing a minus b over n when we switch the bounds. So that's negative b minus a over n. So now that I've done that, I can actually figure out the question. And that is that the integral from -1 to 2 of f of x dx is equal to the integral from -1 to 1 plus the integral from 1 to 2. And this one we figured out was 5 for this integral. And this integral was given as 3. So our answer is 8. In this example, we are given that the integral from -5 to -3 of f of x is 21, and the integral of, sorry, this should be a -5, -5 to -3 of g of x, so this is a different function, is 7. So in this case, our intervals are the same, but our functions are different. And then we're asked to find the integral of 3 times f of x minus g of x. So in this case, once again, we're just going to use our properties of integrals. So this is going to be 3 times the integral of f of x minus the integral okay, 7. So we end up with 63 minus 7, which is equal to 56. And we're finished.